We are at a historic turning point. This video explores how superabundant, near-zero marginal cost energy is poised to fundamentally rewrite the rules of global industrial dominance between 2020 and 2040. We are witnessing a phase change, not just an energy transition. Legacy models often fail by viewing solar, wind, and batteries merely as substitutes for coal, ignoring the radically different physics and economics that now define our energy systems. We have crossed the economic event horizon. Solar is now the cheapest energy source in history. With generation on-demand parity, the cost of decentralized energy is falling below the operating costs of traditional fossil fuel infrastructure. We are shifting from an extractive paradigm, characterized by scarce fuels and volatile markets, to a stellar paradigm. This new model relies on technological assets deployed to harvest ambient energy, creating a distributed and resilient system. To ensure true grid reliability, stellar energy systems must be sized to meet peak essential demand during the most challenging winter weeks. This architectural requirement is a deliberate design feature, not a limitation. Because we build for winter capacity, the system naturally generates a massive superabundance of clean, near-zero cost electricity during the rest of the year. We call this superpower. The math here is non-linear. In a stellar energy system, a modest 20% increase in capital investment can yield as much as a 200% increase in energy output, defying the traditional logic of legacy economics. Like a star, once an energy system crosses the ignition point, it becomes self-sustaining. We are moving from a world of entropy and depletion to one of negative entropy, where we see growth without the need for destructive resource extraction. This flips the script on conservation. The old rule was to minimize energy consumption to save money. The new rule is to fiercely maximize the utilization of free, clean energy to outcompete rivals. Consider the potential in manufacturing hubs like Bangladesh. If energy costs become negligible, the constraints on industrial scale are obliterated. Capital shifts from paying for power flows to investing in physical expansion, making extreme growth a mathematical certainty. The true power of this shift lies in creating, quote, killer combos. By co-locating manufacturing with thermal capture, AI labor, and automated logistics, industries can soak up zero-cost electricity to build virtually invincible supply chains. The next leap is cognitive superpower. By dropping energy costs to zero, we provide the fuel for artificial labor. This enables AI and humanoid robotics to operate on factory floors without the constraints of traditional power costs. This leads to true industrial sovereignty. Stellar energy ends our reliance on volatile global fuel markets and fragile shipping lanes, decoupling the industrial engine from extractive geopolitics and ensuring systemic economic independence. The stellar industrial engine embeds land, labor, and capital directly into the technology. When energy acts as a limitless stock rather than a scarce flow, exponential human prosperity becomes the logical output of our industrial system. The era of energy scarcity is permanently over. This is a race, and those who adopt stellar architectures earliest will capture the future of global manufacturing. The ignition point is now. When Tony Seba says energy is shifting from atomic to electronic, he means humanity is moving away from extracting and burning physical atoms, fossil fuels like coal, oil, and gas, and moving toward capturing pure electrons, solar and wind power.